Dr. Blewitt, for those of you who are familiar with FPWR, we've funded Dr. Blewitt before. She has a really interesting strategy for genetic therapy where she is knocking down this protein SMCHD1 as a way to activate the silent maternal chromosome in PWS. So when you reduce SMCHD1, you get expression, for example, of MAGL2 and the other protein coding genes on chromosome 15. So that's a really interesting approach, and in other funding and with other funding that she's got from other agencies, she's continuing to advance that project. But it's an incomplete activation. And so one thing she really needs to understand is, how does the chromosome change when SMCHD1 is inactivated? And so that's what this project is. It's really to gain an understanding of how the landscape of the chromosome changes with and without SMCHD1 as a step towards doing sort of the most effective gene activation that we can in the region. So the goal here is to determine the chromosomal landscape on the maternal chromosome that every person with PWS has. And if you'll recall, what we're trying to do is activate the genes. All of those blue genes are sitting on the maternal chromosome. They're just inactive. So we're trying to unsilence them and understand how that changes when this particular regulator is missing. So this study uses cutting-edge genomic technologies to optimize a promising approach for PWS genetic therapy, which is a good thing, obviously. In addition, it should give us some more insight into the chromosomal landscape of that region, which would be important for any genetic therapy approach. And you may recall that FPWR is supporting several different approaches to doing gene activation because we don't know which one is going to work the best. But this information will provide insight for anyone who is doing genetic therapy for PWS. So it has a high translational potential, not only for this project, but for other genetic therapy projects. So the long-term goal of this study is to pave the way for more efficient maternal gene activation to treat PWS.